Ph261 homework problem number 5. Okay, so with this one, just like all the rest, the problem is spring and block are arranged in the arrangement of the figure below. When the block is pulled out to x equals plus 3.5 centimeters, we must apply a force of magnitude 380 newtons to hold it there. We pull the block to x equals plus 13.5 centimeters and then release it, and then it says for figure A, B, C, and then we're given some of the following scenarios. So back to what we are given. So given, what we have is the x initial, or I guess the x that the block is held at, for how much it takes to hold it there while the spring is trying to act against it, is going to be x equals 3.5 centimeters. And you know what, just for the sake of it, we're just going to convert everything to meters right off the bat. So it's going to be 0.035 meters. And that is at a magnitude of, so it's going to be force magnitude of 380 newtons. And we know that the spring constant is going to be 1/2 K, which this is the spring constant in Newton meters, x squared, and this here is the displacement. And this is for work done by a spring. So this is going to be x final squared minus x initial squared. Final minus initial displacement, that'll give us the distance. Okay, now that we know all these, to get K, first we look at the force, 380 newtons. And this is the force required to hold the block there. So that means that the spring constant, which is the force required to hold the block, is going to be these two in terms of Newton meters. So this is going to be 380 divided by 0.035. Let's get the calculator. And oh boy, the number here is equal to 10,857 Newton meters. All right. So now we know that is what K is, and now we are going to take half of that. So now divide this by 2, because it's 1/2 K. Right here, it's 1/2 K. So if we divide this by 2 really quick, we get, let's say this equals K, 1/2 K equals 5428. Okay, so now we have, for this, let's see for A, B, C, let's see for all these. So for A, it's going to be work done by the spring equals 1/2 K, which we have found to be 5428, times, this is going to be, let's see, that's initial, that's final, so this is going to be, okay, again, that's in centimeters. So this is actually going to be 0.035 squared minus, and this just looks like 0.065 squared. Now let's multiply that quick. Oh, I realize the answer is still there. Disregard those. Disregard. Oh no, disregard those, please. Okay. It's going to be minus 0.065 squared okay. Forgot it's a negative, it's a negate. So negate this is all going to be negative. So we can just put a negative here. So the answer is going to be 16.28. Okay, so now for B, work done by the spring is going to be again 54.28 negative, and it's going to be final minus initial. So it's going to be negative 3.5 or centimeters, 0.035. Squared minus, I think this is again still 0.065 squared. And now negating this initial one here, because that is the difference, we are getting hold on. Okay, yep. We are getting again 16.28. Apologize for the downtime. I have no clue what was going on with my calculator. So now we're gonna have C, work done by the spring equals 54.28, and now it's going to be negative 0.065 squared minus 0.065 squared and this equals 0, and then D, if we have any space for it, WS equals 5428. And this is going to be 0.065 squared minus 0.065 squared. Never mind. No, it's going to be actually minus 135. Or 0.135 squared. Apologies again. It's final minus initial. This whole thing is 135 squared minus 0.065 squared. Okay, and then we get a negative 75.99. Or, to round up, 76. So that's how we get these. Make sure you input it in your calculator more like xf squared minus xi squared, more like this. If you forget the brackets or have things out of place or put the square somewhere else, you might get some goofy answers. So this way, this template here seems to give the more accurate answers. So other than that, yep, that's it.